Students, let us solve another question of mensuration, standard 10 CBSE, volume and surface area. Here is the question. A cubical block of side 7 centimeter, the side is 7 centimeter, is surmounted by a hemisphere. Hemisphere is surmounted on it, placed over the cubical block. Question is, what is the greatest diameter of the hemisphere? So hemisphere, a small hemisphere can be placed, or very big hemisphere also can be placed. Now the question is, what should be the greatest diameter of the hemisphere? Also find the surface area of the solid. After placing the hemisphere, you have to find the total surface area of the solid. So the greatest diameter would be equal to the side of the square. So in the solution, you can write the first answer. The greatest diameter will be equal to the side of the square, that is 7 centimeter. Second question, you have to find the total surface area of the solid. Now what happens? Now I'm showing you practically one thing. Suppose it is top, this is the top of the hemisphere. Top of the square. The top of the square will look like this, a square. If you place, this is hemispherical in shape, okay? So if you place over it, what will happen? Suppose it is touching all the sides. I'm redrawing it because greatest means it must touch all the sides of the square. Suppose it is touching all the sides of the square. Okay, so this is the greatest hemisphere placed over here. Now what should be this area? Suppose the hemisphere is not here. The area is equal to, this side is 7, this side is 7, 49 centimeter square. If you place the hemisphere, what will happen? It will reduce the area equal to the circle of radius 7 by 2 centimeter. It is half the radius, 7 by 2 centimeter. This portion will be covered by the hemisphere. Only this portion will remain uncovered. So it means pi r square is reduced. Pi r square area is reduced. Area equal to the circle is reduced. And how much area is increased? That is equal to the surface area of the hemisphere. That is 2 pi r is increased. So actually pi r square is reduced and 2 pi r square is increased. So in total pi r square is increased. Total area increased. It is covered pi r square and increasing 2 pi r square. In total area it is increasing pi r square. Okay, so let us solve the question. So area of the curved surface area of the hemisphere, you know it is pi r square. So you can write total. What you have to even find the surface area of the solid. So simply write surface area of the solid. Surface area of the solid equal to surface area of the square, that is 6a square, plus surface area increased is 2 pi r square, that is by the hemisphere, and the surface area decreased due to the hemisphere placing on it. Abhi just I told you, if you place it, it will decrease the area equal to pi r square. So it is pi r square. So it is 6 into a is 7 square, plus pi r square only. If you subtract, you will get the pi r square. 6 into 49 plus 22 by 7 into what is the, this is the diameter of the hemisphere is 7 centimeters. So radius is 7 by 2 into 7 by 2. 7 by 2 is square. This much centimeter square. It's 294 centimeter square. Plus you cancel it. You cancel it by 11. 77 by 2 centimeter square. 94 plus 38.5 centimeter square. It will give you 332.50. You can write centimeter square. This is your answer.